Hello, girls. I hope you're staying safe at home. Welcome back after the break. So, class 8, today we will start with the first chapter, that is the language of chemistry. Now, I know you have been doing chemistry since class 6 and you know what chemistry is. Chemistry, you know, it is a branch of science where we study about matter. Now, when we talk about matter, we are talking about anything that has weight and occupies space. And so, in chemistry, we are going to learn about matter, that is, what it is made up of, what is its nature, what is its structure, and what changes you will see when it is put to different conditions. Now, there were many theories in the beginning which actually helped us to discover the real essence of matter, that is, what matter really is today. Now, the basic unit of matter in any state, you know, the smallest part of matter is molecules. Okay. Now, this is because molecule is the smallest particle of matter which has independent existence. When we talk about molecule, or when you are to define molecule, you will define it as molecule is the smallest particle of matter which has independent existence. Okay. Now, when we talk about molecules, first we have to know about a pure substance. So, what is a pure substance? A pure substance is one which is made up of molecules which has the same types of atom or the same kind of atom. So, that is your definition for a pure substance. So, please underline the definitions. Now, for example, carbon dioxide gas is a pure substance. All the molecules are made up of two oxygen atoms. What is the formula of carbon dioxide? CO2. So, the molecules of carbon dioxide is made up of two atoms of oxygen and one atom of carbon. So, it is a pure substance. Now, the molecule may contain similar atoms or dissimilar atoms. That means, supposing your carbon dioxide has dissimilar atoms, carbon C, oxygen O. Now, if we are talking about a molecule of oxygen O2, that means oxygen is made up of two similar atoms, that is O and O. Okay. So, a pure substance in which a molecule is made up of atoms of the same kind are called elements. So, oxygen is an element. Okay. And carbon dioxide, you know, is a compound because it is made up of two different atoms. Now, to define an element, it is a simple and pure form of matter which cannot be decomposed into simpler substances. That is, the only substance that you can get if you break up oxygen, you will get oxygen atoms, nothing else. Okay. So, all elements, you know, are made up of atoms. The smallest particle of an element which represents all the properties of an element. So, that means in oxygen, what is the smallest particle of oxygen? One atom of oxygen. That means this atom of oxygen will have all the properties of oxygen, the element oxygen. Okay, whether it is oxygen, whether it is ozone, O3 is ozone. Okay, so when we define an atom, kindly underline, an atom is the smallest particle of an element which may or may not exist independently. Now, for example, when I talked about oxygen, if I just write O, we cannot call it oxygen gas. It is an oxygen atom. It cannot exist independently. Two atoms must come together, okay, to form oxygen gas. So atom is the smallest particle of an element which may or may not exist independently. So, in this case, it cannot exist independently. It becomes just an atom of oxygen. But supposing if we take, say, for example, carbon. Formula of carbon is C. So, carbon can exist independently. This is one atom of carbon and it is an element C. So, it can exist independently. Okay. But remember that the atom can take part in a chemical reaction. So, when we are talking about an atom, it is the smallest particle of an element which may or may not exist independently, but it can take part in a chemical reaction. This is your definition for an atom. Okay. Now, a set of atoms of the same type together forms the molecule of an element. Now, for example, oxygen. 2 atoms of oxygen, it came together to form oxygen gas. Okay, so a set of atoms, that is 2 atoms of oxygen of the same type, O and O, it came together to form one molecule of element oxygen. This is one molecule of oxygen element. This is one atom of oxygen, one atom of oxygen. So the number of atoms in a molecule of an element is called its atomosity. So what is atomosity? How many atoms are there in one molecule of the element? So molecules can be mono. Mono means one atom, carbon. Diatomic, oxygen, O. 2 di means O. And even poly means 3, more than 3, ozone, O3, polyatomic, more than 2. Okay, so monoatomic molecules, elements having only one atom in their molecules. Noble gases like helium, neon, argon, krypton, xenon, radon, they have one atom each in their molecules. So the atomicity of noble gases is 1. The atomicity of oxygen is 2. Atomicity of ozone is 3. Okay, so the atomicity of metals like sodium, potassium, magnesium, copper is also taken as 1 because they are made up of only one atom. One molecule of metals are made up of only one atom, that is, they can exist independently. Okay, so the atomicity of element carbon is also 1. So noble gases, metals and carbon are monoatomic molecules. Now diatomic, as I already told you, which have 2 atoms in their molecules, hydrogen, oxygen, nitrogen are examples. Triatomic, elements having 3 atoms in their molecules, ozone. Tetra means 4 elements having 4 atoms in their molecules, for example phosphorus, P4. And octa, octa means 8. So elements which have 8 atoms in their molecules, like sulfur. Sulfur, generally we write S as the formula or the symbol, okay, but actually it is S8. That is, one molecule of sulfur actually contains 8 atoms. So when we talk about a molecule, it is the smallest particle that has the capability to exist independently. That is your definition for a molecule. So the molecule of an element exhibits all the properties of that element. Now when atoms or molecules of different elements combine in a fixed molecule, that time, remember in the beginning I talked about carbon dioxide, CO2. Okay, that is atoms of different molecules. They come together, they combine in a fixed ratio. Fixed ratio means 1 atom of carbon and 2 atoms of oxygen, not more than that. So what do they form? They form a compound because the atoms that combine together are different. It is not same. And similarly, there are other compounds. Many compounds are there. Examples, you can see sodium chloride, NaCl, water, H2O, ammonia, NH3. These are all molecules of a compound. Children, please learn all the formulas. It is very important. You have to know all the formulas. Now, there may be 2 or more kinds of molecules. They combine to form mixtures. When we talk about mixture, we are talking about an impure substance. It is not pure. Now, supposing we take salt and sugar and mix them together, it becomes a mixture. Now mixture can either be homogeneous. Okay, homogeneous means similar. Now supposing if we take a spoon of sugar or salt and put it in water, it becomes a mixture of water and salt. So if you taste it, it will taste the same throughout, isn't it? And heterogeneous means if you put sand in water, it will not have the same composition throughout. Okay, it has non-uniform distribution of the molecules, so it becomes heterogeneous. Homogeneous means same, heterogeneous means different. So salt solution is a homogeneous mixture, whereas muddy water or sandy water is a heterogeneous mixture. Okay, so the names and of elements and compounds are abbreviated by using certain symbols and formula. Okay, long time back, before 1600 AD, people who studied chemistry, alchemists, they try to represent the substance that they use for the experiments by different kinds of pictographic symbols, like picture, such as a triangle for the earth, a crescent for silver. Okay, so they did not have, they used pictures instead of certain symbols. So Dalton used some other types of symbols to represent elements such as circle for an oxygen, circle with a dot at the center for hydrogen. So this is how they used long time back. So you can just take a look. Of course, you don't have to learn this by heart. Dalton symbols of elements, you can just see how he used it. But later, John Jacob Berzelius suggested that the initial letter of an element written in capitals should represent that particular element, such as O for oxygen, H for hydrogen, C for carbon. But in some cases, the suggested symbol did not agree with the English name of the element because it was similar, and so that is why some of the symbols were taken from the Latin names. Because, supposing we take, say, silver, oxygen and ozone. Okay, oxygen O, ozone same. So there were many, like, calcium starting with C, carbon starting with C, so copper, C. Okay, so that is why many names were taken out from Latin. The Latin names were taken out and then the symbols were used accordingly. Okay, so children, we will stop here today and kindly go through this table and write down the name of the elements, the symbol and their Latin name in exactly the same form for your assignment, and you keep it. I will let you know in the WhatsApp group when you are supposed to send the assignment. So till we meet again, children, stay safe. God bless you.